Hello students, let's have a discussion today. Suppose these are some rods we are having and we are considering this as one line, second line or third line. We are just considering it. Okay, now I'm just crossing these two lines like this. Now you can see these both lines have one point in common. So these two lines are known as intersecting lines, and the common point is always known as the point of intersection. Now look, one more thing in this. If we join these two lines like this, can we say them intersecting now also, as they are not crossing properly like this? They are not crossing like this, but they are meeting at one point. Yes, then also they are intersecting lines because they have this point in common. Okay, now let me put these two lines like this. Now if we look to them, then we can see no point in common if we look this. But here is one important thing. These are, we are considered as lines, and the lines properties, they are moving on both the sides. We can move and on both the lines. If we produce them, can you see, if we produce them, then after producing, definitely they will meet somewhere and they have this point in common. So we can say these two lines are also intersecting lines. Now next thing, we have two lines maybe in this form, and the third line is just crossing the two lines at two distinct points, because this line is crossing this blue one and they are intersecting at this point, and the same this line is intersecting this line at this point. So in this condition, if a line intersects two or more lines at distinct points, that is known as a transversal. This is the different color. This is known as the transversal. Now we have some important results related to the transversal, and let us consider two lines and one transversal, say P, and let us name the angles made by the transversal with the two given lines. Okay, we have made all the angles made by the transversals. Now the names are given here. We can give the names to the different angles. And what are those? You can see these, the 3, 4, 5, 6, they are towards the interior of these two lines. So these angles, angle 3, angle 4, angle 5 and angle 6 are known as interior. What interior? Interior angles. Next, as these are known as interior angles, and so what should we say to 1, 2, 7 and 8? So these are known as exterior angles. So what are exterior angles? Exterior angles here are angle 1, angle 2, angle 7 and angle 8. So these are the names given to them. Now one more important name I am going to tell you. Now just look to angle 1 and angle 5. One is towards the exterior, then we leave this angle, and then angle 5. This angle 1 and angle 5 is known as pair of corresponding angles. Pair of corresponding angles. So angle 1 and angle 5, they are known as pair of corresponding angles. Now after getting the knowledge of this, can you think what can be the other pair of corresponding angles? Yes, you may be thinking right, that angle 2 and angle 6 also forming the pair of corresponding angles. That's all. No, we have two more pairs, and those are angle 3 and angle 7, angle 4 and angle 8. So these are the four pairs of corresponding angles. Now, the fourth thing which we're going to discuss is pair of alternate interior angles. Alternate interior angles. So what are the pair of alternate interior angles? Now, interior, the interior are these only, so from those only. So alternate is angle 3 and angle 5. So these are the alternate interior, but not only one pair. What is the second pair? Angle 4 and angle 6. So these are alternate interior angles. Now the fifth is alternate exterior angles. So alternate exterior angles are 1 and angle 7. They are exterior and alternate. So 1 and angle 7. And what is the second pair? 2 and angle 8. Angle 2 and angle 8. So these are alternate exterior angles. Now pair of interior angles on the same side of transversal. So what are the pair of interior angles on the same side of transversal? That are angle 3 and angle 6. They are interior also on the same side of transversal. And angle 4 and angle 5. So we can write 4 and angle 5, and the second pair is angle 3 and angle 6. So they are the pair of interior angles on the same side of transversal. Now, one more type of lines we are going to learn. Now, you can see this is a page which is ruled, and the ruled page always have some lines, and these lines are always parallel. So these types of lines are known as parallel lines. Means the lines which never meet anywhere. These lines are parallel lines. We can take an example of this ruler. If I am going to draw the two lines on either side of the or edges of the ruler, then they also never meet. So these form a parallel line. And also you can look for that railway track. Always on the railway track that never meet. So that is also an example of parallel lines. Even I can show you this duster. The edges of this duster are also parallel. Now we have some important results related to parallel lines and transversal. If we have two lines, suppose L and M, and these two are parallel, and we have one transversal, that is P, then what are the important results? Here always each pair of corresponding angles are equal. Do you remember what were the corresponding angles? Like angle 1 and angle 5. They form a corresponding, so they are always equal. Angle 1 equal to angle 5, angle 2 equal to angle 6, and angle 4 equal to angle 8, and angle 3 equal to angle 7. So these all are corresponding pair of corresponding angles which are always equal. And the second result is each pair of alternate interior angles are equal. Means angle 3 equals to angle 5 and angle 4 equal to angle 6 always. And the third result is each pair of interior angles on the same side, 3 and 6, 4 and 5, they are on the same side of transversal. These are the pair. So they are supplementary. Means angle 3 plus angle 6 is equals to 180 degree always, and angle 4 plus angle 5 is always also equals to 180 degrees. So these three are very important results. And not only this, if in some problem in solving some question, if these results are given to you, anyone, then we can say that L and M are parallel. Suppose these are given and it is not given that L and M are parallel or not, then if they are equal, then L and M are always parallel. Now Let's start the try these of page number 104. First is you need to tell the examples of the surroundings where the lines intersect at right angles. Here it is asked about right angles, in which the two lines intersect, but they intersect at right angles. The simple examples are here, that you can say edges of a paper sheet, or you can say edges of this book. They are also, you can see these two edges, they are also meeting at 90 degree. And you can say leg and top of the table. In these type of examples you can write in the book itself, and you can think of more also. Now second question, let us start, have a discussion. So the second try these is find the measure of the angles made by intersecting lines at the vertices of an equilateral triangle. So what we need to find, this is the equilateral triangle given to us, and we need to find that what is the measurement of this angle, as these two are intersecting. So we need to find out the measurement of these angles. So for that, let us consider this is an equilateral triangle ABC. As we know that the sum of all the angles of an equilateral triangle is 180 degrees, and they always are equal. So in this question we suppose that as they all are equal, so we supposed that it is of x degree. Now as we know the sum is 180 degree, so when we add all three angles, the sum is 180, and we can put the value, as we have supposed that the measurement is x degree, so we can put the values of each angle as x degree, x degree, x degree. We can add them 180. So after solving, it becomes 3x degree, 180 degree. Now x equals to 180 divided by 3. So after solving we get x equals to 60 degrees. So hence what we can say, that angle A equal to angle B equal to angle C equal to 60 degree. Means these two lines, or these two, they intersect each other and they meet at an angle of 60 degrees. Now the question number 3. Draw any rectangle and find the measures of angles at the four vertices made by the intersecting lines. It is said that you have a rectangle, okay, and it is given to you, and you know in rectangle they are intersecting each other. These two are intersecting on this point, these two here, and so on. So this is a property of rectangle, that they always the adjacent lines, they always intersect at an angle of 90 degree. So it is asked that what angle it is made, so it is 90 degree. Now the fourth question, that you have to just write the answer 90 degree on the book only. Now question number 4. If two lines intersect, do they always intersect at right angles? So now I think you come to know, as in question 2, they were intersecting at 60 degree, the different lines, and in question 3 they are intersecting at 90 degree. So how can we say that they always intersect at right angles? They can intersect at right angles also, or other angles also. So we can say no, they always do not intersect at right angles, and do this in book only. Now the try these of page number 105. Suppose two lines are given, how many transversal can you draw for these lines? So the answer is infinite, that you can write in book, because you can draw as many as you want. Second is, if a line is a transversal to three lines, suppose there are three lines and there is one transversal, so at how many point this transversal is intersecting? Now you can see to the three lines, it is intersecting on three distinct points. So the answer is 3. Now do in book only. Try to identify a few transversal in your surrounding. This is just a practical question, that you can see the different transversal around you. You can see the rods of the window, they are also you can see the transversals, and also if you have seen the ladder, in there also you can find the example of transversal, and you can think of more also. Now let us come to the next page, that is page number 106. There are some try these in which you have to name the angles, that what type of angles. Suppose angle 1 and 2, you have to name what type of angle is this. So answer is corresponding angles, and there are other angles also. So you have to name these type of angles here in the book only. Now the next, try these. Let us come on page number 110. There are also some try these in which it is asked, the first is L parallel to M. Why? Now you can see it is given that 50 degree and 50 degree. These are alternate angles which are given to us, that they are 50 and 50, means they are equal. If alternate angles are equal given, so but obvious L and M lines are parallel. So in this way you can write the reasons of other two also in the book only, and its reason, as I already told you, is as the alternate angles are equal, so L parallel to M. So I hope students, till now the topics we have done, I hope you understood them, and you can do these, try these, and you see many examples related to parallel lines, transversal and intersecting line around you also. Thank you.